I'm starting recording then officially. Welcome back, happy garbage day, all that stuff. Our garbage was falling over and starting to leak into the street this morning, so, good times. Got the cans back in before they wandered into the street, though. We've been talking about projects, presentations starting next week, and had some questions about what makes a good presentation and what doesn't. In terms of content, I know I've talked about this before, but I should assume we have imperfect memory of everything you've ever heard. Should that still stand? Yep. So typically in a presentation, the most important thing to think about is who is your target audience and how do you communicate effectively to them. If you are at a conference in your field, then most of the time you would summarize greatly your analysis process to get to the punchline and tell them what you found. I'm asking you to do almost the inverse of that because you all have different areas of research. Some of you have secondary data that's not even part of your research, and it's going to be on all different topics ranging from how babies sleep to how weather affects traffic. Okay, all kinds of things that we're going to hear about. So given that we don't have a lot of background expertise in these topics as a class, I'm expecting relatively brief introduction. So just enough so that we can understand what your study is going to be about. Similarly, a relatively brief method section about your data and how it was created, downloaded, etc. And then the bulk of it, in terms of the points and where I would expect you to spend your time, is describing your analytic process and the results that you find. And it's not just the punchline. I think in order for this to be a useful learning experience, I would like you to focus on the process by which you got there. So I looked at this, that gave me an indication that I should do that. I tried to do that and it broke. So then I pivoted and I had to do this. Like those kinds of things are useful for us in terms of how to deal with these types of data in the future and how to problem solve. I would say that with respect to results, I want them to be presented as answers to questions or hypotheses. You don't have to have directional hypotheses, but at least it's like, I wanted to know this, here's what I found. I wanted to know that, here's what I found. I would say results described in verbal and pictorial form as possible. So nice looking path models, even if they're not the kind that have all the estimated parameters, if they're more conceptual, sort of guiding things, those are helpful. What it makes a crappy slide, so to answer your question, Dan, more explicitly, pasted in output. That will irritate me and your audience. Tables chock full of numbers in 9-point font, where you find yourself saying, I know this is a lot, but just look at this one number. If you know that it's only that one number, don't show the table. I would say make sure that we can see your stuff. So another way that presentations go awry is too small a font, particularly in axes and legends of figures. You want to make sure that we understand what the y-axis is if you make a picture. Limited amount of words. So you would not want to write full sentences and then read them to us. We can all read. Put down enough words to get the idea out. You're allowed to have notes. If you feel better talking with notes, that's fine. I would actually encourage you not to have written notes. I have seen that go sideways more times than not because people get off and they start flipping and then they get rattled and then they can't finish what they're doing because they're like, where am I? Like just have a sense of what you want to say, practice it, and then try to just do your best. Because if you go off script, we're not going to know. Like we don't know what you had intended. So if you skip something or you say something out of order, just like go with it, make it work. Try not to talk too fast. Don't talk like me after I've had 2 Mountain Dews and a coffee. I don't think you can talk too slow, quite frankly. I rarely would see that happen. Keep an eye on your time. I will help you do that, but when you're practicing, try to make sure that you're staying under the limit, 17 minutes tops. That way we have enough time for questions. And then also being evaluated on how you're able to answer the questions. And if the answer is, I don't know, I haven't thought about that, you're allowed to say that. But hopefully this will be like examples of processes that can be followed for these kinds of models. So I don't know if that helps answer your question, Dan, or other questions you have about what I'm expecting, but I tried to be as concrete as possible. Yes?
Yeah, this is very helpful.
Okay.
It's just like a guideline for us to create slides. It's very helpful. Yeah.
Okay, cool.
In the preliminary analysis, sort of stuff in the process, you're looking for like the ideas of the processes, not necessarily like this is the code I use.
Right. Yeah, I don't, no code. unless it's something that you had to do that's completely like novel and you wanted to talk about that as a product of your process. But no, and I don't need like exact p-values for a likelihood ratio test. I don't need test statistics. It's more like we examine longitudinal invariance, then like path model of your model, configural hold, maybe a check mark or something. Metric held except for 2 items, scalar held except for 3 items, like that kind of level of thing. But it wouldn't just be, here's my end result factor of curves model or curve or factors model without showing the steps that you went, or at least describing, I would say, the steps that you went through at that point. Pictures of predicted outcomes would be nice. So like a prototypical growth trajectory, if you have those for different kinds of people, those are usually useful. Plots of like saturated means against your model predicted means to show what you're modeling. That kind of stuff is useful. Let's see, limitations, future directions. I think those things can be in terms of not just the analyses, but also in terms of the broader context of your study. You're allowed to talk about that as well. Where would you like to take this work? Like, do you have plans for it? Could this turn into something? Because I think if you put forth to your audience, here's what I'd like to do, then we can give you some feedback and hopefully some advice as to how you can get there. Okay. So, no papers, by the way. I've answered that question. You're not turning in a term paper. The presentation is the end. Because hopefully, the paper that would result from this would be directly informed by this process and the feedback that you receive. I would hate for you to write 30 pages that all has to be redone because your models were wrong. Like, that's not a good use of my time reading it or your time writing it. So I prefer to do it this way. Oh, and also as a pragmatic thing, ChatGPT is not going to help you with this as much. So I've become kind of skeptical.
I had a moment of weakness and a friend who's like, I've got ChatGPT, you want to know the answer?
Yeah. Yeah, well, I hope that the formative assessment helped disabuse you of that notion.
I knew it was a bad idea from the start, and it was to no avail whatsoever, so.
I got to show you something. Hang on. This is going to take me a second to find it, but only 1 second.
But really, it was because that friend was there.
The friend was there.
Like,
Is that like the
I
devil
can
on your
check
shoulder
ChatGPT.
saying
Yeah,
use
like,
ChatGPT?
literally, like, you want to try some ChatGPT?
Oh, come on, do I have it?
Some of the things I've really liked using ChatGPT for is like helping me find sources.
It finds
helping-
research or references, I mean?
Yes, references.
References.
And I'll
Assuming
go
it
back and
exists.
forth with it if I'm trying to like
Can't
write
find
a
it.
research question. That one typically helps too.
I can't find it, but there's a picture that I found on, I think it was one of the Facebook groups, Reviewer 2 Must Be Stopped, and it was a ChatGPT like diagram of logistic regression. It was the funniest thing I've ever seen. It was like just symbols just floating and like letters that aren't letters.
I think you showed it.
I showed it in class. I just don't remember which class I showed it in, but it was hilarious. So yeah, I don't think it does good with pictures yet, but sometimes it makes up fake references though, so be careful. Yes, that is true. And as it turns out, as you saw in your formative assessment, it just makes up wrong shit. So,
Yeah.
I mean, these are actual answers. I did not doctor these. Okay, this is what it said. And I wanted to do this because I think it's a higher level processing than just answering quick questions, is to try and evaluate what is incorrect about this and what is correct. But also to kind of give you some caution as to like, I know folks are using this, but you got to use it carefully and responsibly and read what it says and evaluate for yourself if it's useful. That's all. I think it's very good at writing generic things. It's not very good at writing highly specific things. That's my impression of it. But let's dive in, shall we? Unless there's any other project-related questions? No? Okay. So describe the process of testing longitudinal measurement invariance. So we did this in example 4B, I believe. Also, there is an example from the SEM class. It is 7B, I think, from that class. We had done that as well. So first thing it says here, longitudinal invariance is the extent to which a measure is measuring the same construct at different points in time. What do we think about that sentence? Thumbs up or thumbs down? I think it's reasonably okay. It is important to test for longitudinal invariance before making causal inferences.
You should like
Yeah.
Causality is tricky and just,
Causality is tricky, but is it even necessary to have the causal part of the sentence? Like, do we need to test longitudinal invariance, period? Would be my thing. Like, yeah, if you're going to have a factor and assess whether the factor changes over time, at a minimum, you need to have some kind of evidence that it looks like the same factor conceptually. And that is relevant no matter whether you're going to try to go to causal land or just stay in associative lands. Like, these things are related. Changes in the observed scores over time may be due to the changes in the construct being measured rather than changes in the construct itself. That's exactly the idea. Is it the same factor over time? The levels, it got these right. A few folks were confused about the terminology. Strict invariance is residual variance invariance, so they're kind of mixing these up. Strict goes with alternatives of strong and weak. So metric is considered weak, scalar is considered strong, and strict is considered residual variance. Doesn't have a special name. So its labeling system is using two different conventions at the same time, which is a little bit tricky. First thing that it got wrong that almost everybody pointed out, configural invariance is met when the same factors are present at all time points and the factor loadings are equal across time. Thumbs up or thumbs down? Yeah, nope, they don't have to be the same. Just the same kind of model has to be fit for each occasion. And I say kind of because you can hedge a little bit. Like if you need a residual covariance at time 3 that doesn't show up at time 1, okay, I can live with that. But if you go from like 1 factor to 3 factors, that's not going to work very well. Metric invariance is met when the loadings are equal and the intercepts are allowed to vary. Is what's written correct? This right here. Metric is met when the loadings are equal and the intercepts are allowed to vary. I would say it's correct, but it's incomplete. Is what?
But like you have to free up other things.
Yes, that's the part. Yeah, we got to free some structural stuff. What do we got to free at this point for metric? It is the variances. So when you put constraints on the loadings, it's possible that the loadings had differed because the factor variances had differed. So you need to allow for that possibility. And my preferred way of identifying the model is to have the factor variance at one occasion, the first one usually, but it doesn't have to be fixed to 1. That way you can test the equality constraints on all the loadings, not having a marker loading that's already fixed to 1 because that involves an invariance constraint, and then free the factor variances at the other occasions. So that is what should have happened. Intercepts and or thresholds, by the way. I don't know if any of you have generalized outcomes that you're going to be shoving into a factor model, but like from an IRT perspective, these would turn into thresholds instead of intercepts, but it's the same idea. Scalar then is met when the factor loadings and intercepts / thresholds are equal across time points. What do we think about that? Thumbs up or thumbs down? Is it correct?
They're like the factor loadings are equal to each other and the intercept thresholds are like held constant, right? But they're not like necessarily directly equal to each other.
Within a factor, the intercepts and loadings vary, but across time for the same indicator, they're constrained equal. Does that make sense? Like, it's not tau equivalent. It's not like you're saying all the items are equally discriminating and all the intercepts are at the same level of difficulty. It's that the same indicator behaves the same way, depending on without respect to which occasion it is. Now, did they forget to free something or mention freeing something at this point? If I've constrained the intercepts to be equal, I'm saying the conditional mean, the expected outcome when my factor is 0, is equal across time. Therefore, what do I need to do else? Free the factor means. Yep. It's possible that the reason that the intercepts grew over time, the indicator means, is because the factor was growing over time. So you got to let that happen. So then you constrain one factor mean, the one that has the variance constraint, usually to be 0, and then you free it at the other occasions. Then the factor can grow or decline as it needs to, and the intercepts would be able to stay the same as expected values conditional on the factor score. Strict invariance is met when factor loadings, intercepts, and residual variance are all equal across time points. What do we think of that? Thumb scale? You can go sideways too if you're like not sure. Yeah? We don't like it? Sideways? What's your issue with it?
I don't know. I'm gonna be fully honest.
You haven't had
I would love
SEM
to
yet.
go over
Yeah.
it.
Welcome to the crash course.
So one, I'm trying to remember what I remembered yesterday about the class.
Trying to remember what I remembered of what I remember. Okay.
But I think that like it's not necessarily that all those things have to be equal, but it's because we're trying to like recreate the variances, right? We're trying to like build the right structure.
We're trying to build the right structure at first, but then we're trying to say the structure holds across time as evidenced by not worse fit as you apply these layers of constraints.
Yeah, and so like it's not that they have to be equal across time points, but they have to be not worse. Like so there are some
Okay.
things that you can allow to like be different, right? Like as needed. You can release some of the constraints, but the not worse part is the important piece.
Okay, so it sounds like you're honing in on two things. The phrase equal, I would replace that with equivalent, which might be a semantic distinction, but I think it means like equal-ish. You know, like you can put the constraint on, and then the reason that how you would evaluate whether that's okay is change in fit. And I think the second part of what you were saying involves partial invariance, which is not mentioned here at all. So what if you have one item whose loading wants to be different? Is it game over? No, let it happen. If you have one intercept that wants to be different, game over? No. It's fine. And if residual variances, I would say, are probably the least important part of the story because it's the amount of variance that's due to not the factor changes over time. Like, who cares? It's not going to make that much of a difference. I had a thought, and now it's gone. Okay. Anyone know what I was going to say? I'm with you. Like, I don't remember what I remembered just now. So partial invariance was not part of the story. I will tell you while there are no like hard and fast rules as to how partial it is, the more things you have to free, the more tenuous your ground is in saying this is the same thing. But for those of you who are working with very large sample sizes, you may have a tremendous amount of power to detect non-invariance. And so then you kind of got to hedge like, yeah, it's different, but that's because this loading is 0.36 and this one's 0.37. And I can live with that. So there's not a lot of effect size conventions that are used in this field, but I think there should be, and that would certainly be an area of research that would be useful if that were interesting to you. I've seen a couple papers, but not a whole lot. All right, now here's the one that I think to me jumped out the most. The process of testing involves these steps. Estimate a confirmatory factor analysis model for each time point. I will replace that with the appropriate measurement model, because if you have categorical indicators or count indicators, it would need to be a different kind, but let's just say that that part is fine. Compare the fit of the CFA models across time points. Completely wrong. That is not what we do. All the time points are in all the models. So this makes it sound like I fit my model at time 1, yay, it fits. Next analysis, I fit my model at time 2, yay, it fits. There's two things wrong with that. Number one, we have repeated measures. So we can't just isolate occasions as separate things without paying attention to how they correlate within persons and between persons. Number two, that's not what we're doing to test the constraints. All the occasions are in there, and then we test the loadings, we test the intercepts, we test the residuals as just described. So this is just wrong. Like, it's either badly worded or wrong. I don't know which. If the fit of the CFA models is not significantly different across time points, I don't even know how I would test that. Like, I literally don't know how you would say in separate analyses, this fit is significantly better than that fit. And I don't know why you'd care. Sorry, I'm in a mood today. I'm just like, you're getting opinionated Lisa in front of you. That's what happens when I have too much caffeine.
I support opinionated.
Yeah.
Yes, me too.
It's better to be wrong than vague. That's what I say. And I'm kind of anti-AI because I see it too much and it makes me frustrated. And even if I don't call people out on it, know that I can tell the difference. And it's registering in a way that is not positive. If the fit of the models is not significantly different across time points, then the measure is longitudinally invariant, whatever. If it's not, it may need to modify it before making causal inferences. No, you need to modify it, period. For example, the researcher may need to remove items or add them. Well, if you had more, why weren't they in there in the first place, would be my question. Or they may need to modify the way in which the items are scored. Oh, hell no. Oh, my model didn't fit, so I'm going to start messing with my data until it does? No. What about this adding and removing items? Do all items have to be measured at all occasions? Is that a requirement? Erica, you said no, definitively?
All occasions,
Mm-hmm.
but all the predictors have to be there.
The predictors, yes, but items are outcomes of the factor. What do you think, Zoomers? Do we need to have all the same items at all the same occasions?
I think no, but you need most of them to be somewhat similar.
Yeah, you got to have overlap. That's the thing. You can piece it together if you have overlap. If you have completely different items at each occasion, you're done. There's no comparability. But you can add them as you go. And that's the idea of like vertical equating or vertical scaling in the IRT world. So for instance, the ISASP is another word that I have a hard time saying. I don't remember what it stands for, but it's what ITP creates and administered. My son took that measure at school last week. And they have a vertical scale such that third graders are expected to have this score. Fourth graders are expected to have this score. Fifth graders are expected to have this score. And so because the items are aligned and calibrated such that it's the same trait over time, according to what they're saying, then you can see how much he's grown in math because it's being measured by, in part, the same items that he answered last year. So I think that is a very good way to proceed if you're trying to measure development, because you don't want to be stuck with items that are too easy or too hard. You want to be able to kind of customize them as the people are moving along their process. So, and no, modifying the way they are scored would not be my preference. That would be like in case of emergency kind of thing. All right. Any other thoughts on this one? Anything I forgot to complain about? Been pretty thorough. All right. Then we'll move it along. Okay, this one.
I also appreciate that you didn't put the two AI ones back to back.
Yeah.
Like there was like, oh, okay, thank goodness. A normal question.
Yeah, see, this is like foreshadowing because I wanted you to think about what a latent basis model is and then read what it says it is. So there's a term for that, but activation or whatever. Prompting? Or what? Priming, that's what it was. Another P word. Yes, I remember that from my cognitive and social psychology days back as an undergrad. So latent basis models of change over time, how do they work? And when would we use them? We'll tackle the first part. So what is this that I'm talking about? Step one. I know it's been a minute. What is a latent basis model?
Instead of manually carving up
Instead of manually carving up
the variances,
the variances.
you let the model figure out what's between and
Oh, so nope, different thing.
okay, dang.
Yeah.
All right.
Terminology. Latent centering is what you're describing. Latent centering is treating a predictor as if it were an outcome, letting the model carve up what's intercept, what's residual, what's change. Yep. Or what we just called multi-level last semester without a special name for it. That is not the same thing, but it has the same first starter word. I know, synonyms versus not, it's very challenging. Latent basis is the thing where some of the factor loadings are estimated. Does that help? So like one loading in an SEM world where you have a change factor, one loading might be fixed to 0, one other loading might be fixed to 1 or the last occasion. And then what happens to the other loadings in this process?
They would get estimated, like kind of in between.
Yes, estimated. Yes. And what do they become? Kendall, I'm going to call on you, or Taylor, because I can see you're both thinking.
I think it just becomes a like latent factor. I don't know, it becomes a circle, and I can see like a little
Yeah.
picture.
I'll take that. It's a circle. It's a change circle. Kendall says they show how much change has happened at each occasion. Yeah, that's the 0-1 scaling. That's usually how people talk about it. It's the proportion of change that has happened by that occasion. So it's essentially estimating time. In the growth model formula, when you have, intercept plus slope times time, the slope part is the mean of the change factor. Time are the estimated loadings. So would it be helpful if I got out the thing that we did with that to look at real quick? I think it might be. That was example 4B. I know it's been a minute. But I had a feeling that several of you might be trying to use these models in the SEM world, so I thought I would have us revisit that. This is example 4B, and it would be towards the end of it, but before the last one, so let me find it. This is invariance with my pictures that I stole. Keep going. I know what I'm looking for. It's not this. There we go. That's what I wanted. So latent basis parameterization. And in this example, it is a model of a latent factor that is growing, but you can use these for observed variables. So there were a few comments that got those sort of confounded. I showed them both in the same example, but you can do latent basis anytime. So the idea then is, like if I'm predicting what the mean is over time, my fixed intercept was 0, because this was a latent factor whose mean was fixed to 0 for identification. The 0.340 was the mean of the latent basis change factor. So it was actually negative 0.3. So in this example, they were declining by 0.34 per unit time. And so the fact that I put 0 at the first occasion and 1 at the last means a unit is the whole study. So this is like the total amount of change that has happened in this metric, in which the first occasion is in a z-score metric because of the way we set up the model. So it's mean 0, variance 1. So we're declining across the study by about 1/3 of a standard deviation on average. So then the things that are in parentheses is the time variable. And that is what the latent basis loadings become. So if this were to be linear change, like this would be 0, this would be 0.33, this would be like 0.66, and this would be 1. Like equal interval change would be linear. So these numbers were estimated instead, so it looks like there is relatively more change happening between 2 and 3 relative to what you would expect as linear. So the latent basis loadings are occasions. Like that's how they function. It's weird, but it works. Yeah.
So is that like better for unbalanced time when you don't know, or is it like how does all of that come together?
There is no such thing as unbalanced time with this, to the best of my knowledge. This is a balanced time situation. Yep. So I don't even know if M+ would let you try to do both at the same time with t-scores and latent basis. I don't know what that would look like. Similarly, in this particular model, these are fixed. So they're not individualized. A few folks wrote that down. No, this is the average, this is the shape of change. And you can have individual differences in that extent, but you can't have different shapes. Like if you fit a random linear model, the only kind of shape you're going to have is this. And whatever this works out to be, like you can have that to different extents, but it's the same shape. I am aware of a paper, and I think I put a link to it somewhere, where you can have these things be random, but in practice, I don't think anyone's going to have enough data to pull that off. And in that example, they actually shut off all the covariances among all the random things at level 2 to make it converge, and I'm like, I don't like that either. So, a little sus. But this is how they work. We nail down 2 of the loadings for identification, doesn't matter which 2, and then we estimate the others to create some kind of empirically based nonlinear trajectory. So we're not hypothesizing, oh, it's quadratic, let's see how that fits. Oh, it's piecewise, let's see how that fits. Oh, it's exponential, let's see how that fits. We're letting it figure it out. And you can do this with any kind of model as long as you have balanced time. So when would it be useful then? The second part of the question.
This is when you want to figure out if there's a higher order, or you want to see if there's something above that to.
That is a factor of curves model, which is the end of that example, but unrelated to the question. Yeah. In hindsight, I should have broken this into separate examples because they're getting like fused in folks' mind. In this case, I would say one answer is when you don't have like a clear trajectory and you're like, I don't know, like what fits this? Like when you got some kind of nonlinear, good. And you're letting the model figure out what kind. Another time this would be useful is if you have something like a quadratic model and you want to use the linear change factor and the quadratic change factor to predict something else, and they're both going to be really, really related to each other, and it's not going to work that well. If you can get away with one random factor instead of two, and that one random factor has nonlinearity baked into it, then that might be a more parsimonious model that's more likely to have convergence occur. Those are the two that I can think of, at least. There may be others. But balanced time is required, though. I don't know of a way to do this in the MSEM framework. This is only a SEM thing, and that's why it's balanced time. Okay, questions or comments on that? And if you're asking yourself, do I have to do this in my project? No, you don't. Only a few of you, I think, are using the SEM version of this. I think everyone else is in MSEM, so you don't have to do this if you don't want to. It's okay. Now let's see what ChatGPT says. So this one I included on purpose because this is another way that I can usually tell, like, when students write things and they're not sure what they want to say, they throw everything at the wall at the same time and hope something sticks, and that was this answer. There's all kinds of stuff in here that does not answer the question. It's just like, well, is this relevant? I don't know, let's try it. And it contradicts itself, which is even funnier. So here we go. Latent basis models of change are a type of SEM. Sure, I'll give you that, used to study change. They are particularly useful for studying change over time when the data are not evenly spaced. What if the data aren't evenly spaced? We just code time that way. Like if it's 0, 1, 2, 4, fine. That's any growth model. Equal occasions, equal distances between occasions are not a requirement of any of this. Now, if they're talking about balanced time, that's a different story. And it sounds like if they are talking about balanced time, then the data are not, they're useful for unbalanced time. That's straight wrong. They work by creating a latent factor that represents change over time. This latent factor is then used to predict the observed variables at each time point. Latent basis models work that way, but you know what else does? Everything. Every model of change works this way. I make a factor that represents change, and then I predict the observed outcomes. That's not latent basis specific. That's just how SEM is representing growth models. Nothing new about that. For example, how anxiety changes over time, we might select it at 4 time points. Sure. We could use a latent basis model to predict anxiety from a latent factor that represents change over time. Is any of that latent basis specific? Nope, that is any kind of change model. Again, they have a number of advantages. First, they are relatively easy to interpret.
That's wrong.
Straight wrong. No, they're like the hardest kind there is, as far as I'm concerned. They are relatively robust to missing data. No. SEM is, or MSEM is, not that model. It's not even growth models. It's a joint likelihood. That's what makes it robust. They can be used to study change over time when the data are not evenly spaced. I feel like I just read this about 2 paragraphs ago. Yeah.
Couple
3
2,
times.
more.
One more for the charm. They are a valuable tool for studying change. Yeah, I got that part. They are relatively easy to interpret.
Nope.
They are still robust to missing data, like we just learned in the last paragraph. And they can, like, I swear to God, I did not paste this twice. Like, it just spit this stuff out. Here are some more advantages. They can be used to study change over time in multiple variables simultaneously. Any multivariate software will do that, MSEM, SEM, just not univariate MLM without tricking it. And I'll actually, in example 5b, I can show you how to trick it, or at least describe it. It's in chapter 9. Evenly spaced again. Oh, they can study change when the variables are not normally distributed. Is there anything about a latent basis model that addresses distributional assumptions? No. No. What if you did want to study change in a count, or change in a binary outcome, or change in an ordinal outcome? Can you do that? Like in life, can one do that? One can do that. Those of you who've had that coursework, what am I talking about? I think almost everybody here. I think everybody here has. IRT sort of thing. And like if I wanted to predict a binary outcome in particular, what's
Logistic regression.
yeah, I add a link function. Yeah, you can have link functions with these. You can switch out the level 1 distribution, the conditional distribution, but that's not specific to latent basis. That's anything in the world of SEM. So long as you have options for link functions and alternative distributions built into your software, that's the key. Status GSEM has more than other packages, including M+, but it handles missing data differently, so the results tend not to converge, but that one I know for sure has a lot of link functions in it. Disadvantages, they are computationally expensive to fit.
I don't even know what that means.
You don't even know what that means? I don't either.
Time plus is expensive. I don't know what that means.
Like time expensive?
Yes, literally expensive. Yes, M+ costs $900 to purchase new, and you have to pay $175 a year for renewal. Yep. It is computationally expensive, I'll give you that.
But that to me, like, expensive. It's monetarily expensive to do that, but I don't know what computational expense is.
No, this is just nonsense. Like, these are empty words. They really are. I think you could try to derive some kind of meaning out of it, like a Rorschach test or something.
Only because humans are meaningful creatures.
Exactly.
Not because there's anything inherent.
Yeah, scientists can make up a reason for anything. It has a few more parameters. I'll give you that. So let me go back to the thing I just pulled up here. Relative to a standard linear growth model, do you know how many more parameters this would have? Can anyone guess? One, two. More with more occasions, maybe. But 2 is not something I'm going to say, oh my God, that's too expensive. So no. They can be sensitive to the choice of basis functions.
I had no idea what that meant. I was like, what?
What? Any thoughts?
I wonder if maybe they were picking up on, like, the latent thing itself, depending on how the model specifies that.
Maybe.
But we don't necessarily have a choice in that.
Yeah. Zoomers, do you have any inferences that they can be sensitive to the choice of basis functions?
I interpreted it as if like you were doing 0-1 versus 0-4, but I think I was giving it too much credit.
I think that's the only thing that makes sense. If you switch from 0-1 to 0-4, what are you doing? Like, what are you changing in that case?
I guess like what the scale of the whole study means.
What time means, exactly. So if I go from 0 to 4, a unit is, from 0 to 1, 1 to 2, 2 to 3, 3 to 4, whatever that means, whether it's 1 year, 2 years, a month, whatever. And if you go from 0 to 1, that's the whole study. But guess what? Do those things sound like they could be made equivalent by, I don't know, dividing by 5 or some shit like that? Yes. So no, once you rescale, you're just redefining what a unit is. In the same way that you could have change per day and turn that into change per month if you wanted, and change that into change per year. It's up to you. Now, if I interpreted this quite literally in terms of the latent basis itself, we're not choosing it. We're letting the loadings be estimated. That's the whole point. It's empirically driven nonlinearity, where you don't know what the pattern should be and you let it figure it out. So we don't make a choice other than to use the model, which tells us what to do. Bah! They are difficult to interpret when there are a large number of variables.
They just said they were easy.
I know. It was difficult, then it was easy, then it was difficult. Do you think it becomes more difficult to interpret if you have a lot of occasions?
Yeah.
Maybe the pattern gets weirder, but like the idea of it that the occasions are the loadings, like that's constant no matter how many you have. So despite these disadvantages, latent basis models of change over time are a valuable tool for studying change over time. They're relatively easy to interpret, I guess, as long as you don't have a large number of variables. Relatively robust to missing data. And you can use to study change over time when the data are not evenly spaced. Nonsense. So there's very little in this answer that I would say is correct.
If it was from a student and I got that, I'd be like, there's a substance here. You should redo this.
Yeah, that's what I would say. So yeah, not pleased with that answer. And then finally, I think this is the last one. Yeah, the softball. If a time-varying predictor contains individual differences in change over time, i.e. the predictor itself changes over time differently across people, can you use person mean centering or constant centering anymore? Nope. What do we do instead?
Latent centering.
Yeah, some kind of latent centering, turn it into an outcome, make sure that the green change circle is represented for X and Y. Yep. So that one's easier enough. Now, I will tell you that that is my opinion, and that if you read other people's papers, they would have a different opinion. Those papers aren't on your reading list. It's my class. However, they are referenced in a few spots in Lecture 5, which I am now segueing into. Let me see where, yeah, this page. So this one in particular, Usami, this is a review and an organizational framework of all these different kinds of SEM-flavored growth models that have come out in the last decade or so. There's a lot. And there are versions of it that don't have any kind of change slope whatsoever. So there's one in particular that I'm thinking of that has one random intercept, except the loadings aren't fixed to 1, they're estimated instead, and all the indicators of different constructs load onto it. And then they let each indicator have its own intercept to create like a saturated means model, and they say, look, I controlled for time, let's move about the cabin. So like there's stuff like that out there, and you can read about it, or references on here, and then there's more recent stuff about it too, but I like this one. I thought it was useful to organize this stuff, and there's some other stuff here as well that talks about these models. So there are many more out there than what I have time to present even in one semester, and it's continually growing. All right, questions or comments? Take a drink of water here. Calm the hell down. Where did we leave off? More to the point, where should we pick up? Because that may not be where we left off. I was thinking it was somewhere in this neighborhood. But we could also talk about between and contextual stuff again, structured residual stuff again. We have just a few more slides. We should do examples. We can do examples. We can do that too. Anyone else want to weigh in?
Examples sound good to me.
Examples it is. Okay. So you speak up, you get your way. How about some pretty spaghetti plots? So this is the current version of a handout that I have been developing and tweaking and changing for about 10 years, maybe? So it has grown as the choices for modeling have grown, but the story has remained the same. This is data from chapter 9. I have simulated close versions of this and put them in other places, but this is the OG simulation. The story is pretty straightforward. I simulated these data based on real data that were part of a study I helped with when I was a postdoc at Penn State. We're looking at how changes in risky behavior in adolescence relate to changes in parental monitoring. And we have both of those things measured repeatedly. As we will find out, risky behavior grows over time. So this is a composite measure of things you don't want your children doing, like ditching school and shoplifting and drinking and smoking and stuff like that. This is a measure of parental monitoring. Now, there is no change over time on this on average, but if we look at these curves, what does this suggest to you? Just eyeball the picture. What kind of individual differences do you think might be in this variable? There's no wrong answers.
I think they're gonna have differences in how they change.
You think differences in how they change?
Yeah.
What
Like
makes you say that?
Different students are gonna change at different rates. What makes me say that is the giant mess and jumble of all the different lines.
Yep.
In different slopes.
And this is fake data, by the way. It's really ugly. Anyone else want to weigh in? This is an average from 1 to 5 of a scale. This is a sum over here, so they're in different units, but
I feel like it starts bigger than in like an arrow. So
Yeah, hang on,
then
let me do it
some
this way.
people are going down and some people are going up.
yeah, it looks like there's a lot of heterogeneity at age 12 that starts to kind of converge. So in other words, there's more variability at 12 than there is at 18. And whenever you see variance that's changing in one direction, that is a hallmark of random change slopes of some kind. The same thing happens over here. It looks like there's variability that spreads out more as the children age, so there's more differences. And this one here is a different kind of plot. This is time varying monitoring by time varying risky behavior. This is a big old mess.
It's like something my kids might have brought home when they were 3.
Yep, this is an artistic rendering by a 3-year-old of something. But I will spoil the surprise for you. Okay, I'll just tell you how I simulated these data. It turns out that monitoring is good for you. I know. Parents who increase their monitoring more have children who increase their risky behavior less. Between persons. Within persons, there is a negative relationship. At occasions when you are riskier than usual, you are being monitored less than usual. So I set this up deliberately to highlight the problems of smushing, where we have effects in one direction at the between level and in a different direction at the within level. And both make sense, because both can be true at the same time. Your general tendencies as a parent can change, or not change, that's causal, relate to the trajectory of your adolescent. But it's also true that, like, it could go either way. It could be that occasions where you're behaving worse than usual, it's because you're being monitored less than usual and you're getting away with it. Or it could be that you're being monitored more than usual, and so then you stop doing stuff. And so monitoring is working. These models, except for the last page, are all concurrent. So I'm not trying to say like which comes first in terms of which causes. I'm just viewing these as two processes that are happening together over time. Nothing causal here, because these are people. It's not even an experiment. So what I want to show you is about 18 different ways to look at these data and answer that question. But it's the same kind of model in every case. It's just trying to unify across how you would do it in this framework and that framework and that framework. So first thing you can do, trick SAS into doing it. You have not seen this kind of notation before. You might have seen it in the generalized class if you did that, but not the multi-level version. This is what I call a specific intercepts kind of model. So what ends up happening if you were to try to trick univariate software into doing this? Because it's still univariate, you have to stack your data so that both outcomes are in one column. You then create a new dummy code that says if it's a risky behavior outcome or a monitoring outcome. So these act like switches. And then every fixed effect in your model is multiplied by either of these dummy codes. effectively saying, if it's a row that's risky, and that's a 1, here's my growth model. If it's a row that's monitoring, and this is a 1 instead, here's my growth model. So everything is separate but simultaneous. The reason to do this is because you would end up with a combined G matrix that in this case would have the risky intercept, the risky linear age slope, and the monitoring intercept and the monitoring linear age slope. So it would be a 4 by 4. That way you could look at how the intercepts are correlated and the change slopes are correlated. At level 1, the R matrix then would have risky and monitoring at the same occasion be allowed a correlation, but not a correlation over time otherwise. So then if you happen to be higher at 12 on one relative to your trajectory, are higher on the other at 12 as well. That's what that's answering. And so long as you're happy with all of these relationships across outcomes being in the matrices, G and R, 2 and 1, as correlations, then you can do this. Now, Elmer won't do this. It will do the level 2 part, it will not do the level 1 part. I've had little luck making Stata do this. I can't get the R matrix figured out there either. I could get G figured out, but not R. SAS is the only one that I know how to do this easily in. But I used to spend time teaching this, but I've stopped doing that because it doesn't answer a lot of people's questions. So for instance, if you wanted to say, are families with this characteristic, do they have a stronger tie between monitoring and risky behavior? Like that kind of moderation, can't do that by changing a correlation in the matrix. It's assumed to be the same for everybody. You'd have to do that by switching it out to be a fixed effect of one predicting the other and then adding in interaction terms. So there's a lot that really can't be done in that version of it, but I present this as a choice. Okay, here's what can be done then. Model 1 as an undirected multivariate model via long M-SEM. I know that's a mouthful, but I'm trying to hit all the vocabulary words here. So this is long format data. I put the data in the thing. The download folder has the data for this because this is fake data. So the format of it is 1 column for risky and 1 column for monitoring. I have a column for age as well as my indicator of time because this is a study in which everybody started around age 12 and they were measured approximately annually. So I introduced a little bit of noise in exactly when they were measured, so it's not perfectly balanced time, but it's balanced-ish. And it's not an accelerated design where I started people at like 13, 14, 15. They all start around the same point in this fake little world that I have here. Okay. So names, all the stuff that's in the data set. In this case, I went ahead and made time squared. So this is going to be what keeps track of the passage of time. Notably, time 0 is the end in this analysis. So I decided to put the intercept at age 18 because that is the point in which risky behavior is going to be bad for you. You will be tried as an adult. And there's also a lot more variability at the end than there would be at the beginning, so it's a more interesting place to put the intercept. That's a choice. So it's at the end. So in this analysis, I have linear time and quadratic time that I built ahead of time. Attitudes is a time invariant predictor measured at age 12. So it was a fictitious survey given to their parents. I've centered it at 4 because it's measured on a scale of 1 to 5, and most people have conservative attitudes that say, no, I don't want my child doing bad things. Risky is one outcome, and then monitoring is another, and because it's going to be a predictor, I centered it at 3. So average level of monitoring. That way my fixed intercepts and random intercept variances for risky are conditional on something that exists in the data. Missing data identifier as usual. So attitudes is time invariant. Time and time squared are time varying, but only at level 1. So these are not going to be partitioned using latent centering. They're going to be left alone as boxes. Risky and monitoring are not on these lists. They're going to be partitioned in the way that I tell the model to do so. Okay. So anytime you see an R in front of a variable, that's going to stand for risky, and an M stands for monitoring. So within model here, you've seen some of this stuff before, but just in case you don't have perfect recall of how it works. So I'm listing their residual variances as estimated parameters. So these are going to be level 1 residuals left over after controlling for change over time. I've got 3 sets of placeholders for what is going to become circles at level 2. I have the linear effective time for risky. I have the quadratic effective time for risky. This one's going to have no variance, by the way. It was just fixed quadratic random linear. And then I have the linear effective time for monitoring as well. And then at level 1, a covariance. So the same occasion, like the same row of data, risky and monitoring get to have a covariance here. So if I'm higher at age 12 on one, am I higher at age 12 than the other? Same question at 13, 14, 15, and that's assumed to be the same over time. Okay, with me so far? All right, between model then. Stuff in brackets are means or intercepts. So these two, these are referring to the fixed intercepts for each variable in your growth model, the mean of the intercept factor, in other words. The last 3 are referring to the mean of the change factors, what we would have called fixed slopes last semester. So I have the linear slope predicting risky, the quadratic time slope predicting risky, and the linear slope predicting monitoring. I then have random intercept variances, and I have labeled them because I'm going to use them to do math down below. I have linear change slope variances, also labeled to do math down below, and I did not want a quadratic change slope variance, so I shut it off. Next layer is my time invariant predictor of each outcome. I'm asking how parental attitudes as measured at age 12 moderates where people stand on their intercepts and on their change slopes for each variable. Then we get a whole bunch of widths. These are covariances. So I'm essentially setting up the off diagonals of my G matrix right here and saying, I'd like all of them, please. And this is where your conventions for labeling things have to be really tight or you will go insane. But the way I'm doing is like the first thing, and if it's the same variable, then I don't have so this is like the intercept and linear of R, intercept and linear of M. This is the covariance among the intercepts, among the linear slopes, and then intercept for one to the linear of the other, and then vice versa. Okay, questions? So this is the same model as that.
Why
Go
didn't
ahead.
you want the quadratic change variance?
Because in chapter 7, I found it didn't contribute to the model.
Okay.
On purpose, because I didn't want it. But if you have a quadratic change variance, you get to have it, and it would get its own sets of widths. So then rather than having it be a 4x4 G, it would be 5x5. And note that, what is it? Yeah, monitoring didn't have a quadratic. That's okay. They don't have to match. The one thing to keep in mind, though, if you're in that situation, is that if you have a random linear and random quadratic, that random linear is specific to time 0. If you only have random linear, it's the whole time. So they mean slightly different things. If you wanted to get them as comparable as possible, I would mean center time so that time 0 is in the middle, and then they have similar interpretations. Other questions? Okay. So partly for pedagogical purposes and partly to make sure that I know what I'm doing, I created the correlation versions of these matrices. In MSEM, you don't get standardized results unless you use Bayes, and I'm in ML land. So the basic formula here is correlation is covariance divided by the standard deviations of the two variables multiplied together. So that's why I have all these labels here. I labeled everything just for pedagogical purposes, but I need the ones here. So I'm correlating, or computing rather, the residual correlation at level 1, and then all of the various correlations in the G matrix as well. And since I'm down here, these are the 3 that I told you about. So int core is how the intercept for risky is correlated with the intercept for monitoring. So these are people things. So like people who started out higher, or not started out, people who ended up higher at age 18 on risky ended up lower on monitoring. Inverse relationship. So these are between person relationships, people who. Likewise, people who, I wouldn't say improved, increased their risky behavior more over time than other people, decreased their monitoring over time more than other people. Negative. So if you just look at this part, then monitoring is good. Within persons, though, on occasions in which you are being monitored more than usual relative to your predicted trajectory, you are engaging in more risky behavior than usual. So these three numbers are going to show up across all the permutations of this model as like the thing I'm hanging on to try and explain these results. The rest of this, though, is a whole lot. Okay, do you want to roll through these? Try to anyway. So that is my R matrix covariance. Same occasion residuals are related this much. These are my leftover level 1 residual variances for each variable. And note that if either of these were binary or ordinal or counts, these would not be here. Separately estimated residual variances are only a thing if you have a normal model. These are the effects of your time invariant predictor on your intercept and change factors. So for instance, parents who think, this is basically the extent to which they want your kids behaving well. So parents who think that good behavior is more important have less of an increase in risky behavior. There is no relationship on the change in monitoring. And parents who think their kids should behave better have less risky behavior at age 18 in the intercept. And there's no effect of the attitudes time invariant predictor on the intercept for monitoring. Then we get into the G matrix covariances here, which are easier to follow as correlations down below. What does mean R quad? Do the hard ones. Is it a mean? It's not what I would have called it. Yep. This is for risky behavior, the quadratic fixed time slope. The mean of the latent variable that has nothing around it, yes. No variance in this model. I've got 4 things called intercepts. Only 2 of them I would call an intercept. The first 2. These I would have called fixed intercepts last semester. At age 18, risky behavior is predicted to be 23 on the scale on average. At age 18, monitoring centered at 3 is expected to be 0.063 on average. These things, what would I have called them?
Be the slopes?
Yeah, these are the fixed slopes, the fixed linear time slopes, yep. And the reason they are being labeled as intercepts is because they are the center of that latent factor, but the latent factor is being predicted. So they're conditional on attitudes of 4. I would have called it gamma 1.0 and gamma 2.0 in an equation, with some other subscript to keep track of which outcome it is. Residual variances, these are all left over. That's why residual. So these are the intercept variances left over, the linear slope variances left over for that. Here's what we did in SEMland. Ta-da! So in wide data version, this is what it would look like. I've got my indicators of monitoring, my indicators of risky behavior. I have an intercept factor, a slope factor for each of those, and then I have attitudes as a time invariant box, and I didn't want the picture to get clunky, so I made 2 of them. You can cheat like that, I'll allow it. Two-headed arrows means these are all covariances rather than one predicts the other. So I would call this an undirected model in that we're just two outcomes. We're not saying which is a predictor, which is an outcome as a semantic distinction. So then the same exact model in SEM looks like this. The code looks quite different because we have to deal with all the different boxes for each occasion. This is a use of t-scores for unbalanced time, right there. So I have columns in these data for exactly when age 12 was relative to actual 12, and I have that for each of the ages. If I had had balance time, I could have done it like this instead, where I put in the loadings as fixed numbers to convey how much time has passed relative to age 18. So that's why these are negative. Because 17 was 1 year ago, 2 years ago, 3 years ago, and so on. All right, 143. Looks like we are not going to get very far in this.
Can you talk more about the t-scores, the balance time,
Yep.
all that?
Yep. So in traditional wide level SEM, you are assuming that like if you have this box that's age 12, it's exactly age 12. And so you'd put like this is 0, and then like this one's 1, and this one's 2. But if you have someone who came in at age 12.2 and someone else who came in at age 12.5, like that 0 should be adjusted. So in M+, the t-scores option allows you to feed in variables that then say, okay, for this loading, it's going to be whatever this column is stored as. This loading is that column. This loading is that column. This loading is that column. And so you are fixing it to the amount of time that has passed for that person, as opposed to saying it's 1 more for everybody, it's 2 more for everybody, it's 3 more. I think you have balanced time, right?
It's a great question. I think at one point you told me I didn't, but now I'm starting to think maybe I do, and maybe I wasn't listening, or...
I could be misremembering as well, because I've got everyone's data in my head at the same time. I think in practice, it matters more if more things happen during the time scale. So like Taylor, your babies are constantly growing and changing, right? Like you can't pretend that a 2-month-old is close enough to 2-month-old if they're actually 3 months. Whereas if we're studying an 80-year-old and it's like 2 weeks later, okay, I can live with that. They're still 80 enough for me. So I think there's empirical ways to address that, but I would say that if you think your process is sensitive enough that even little deviations are going to matter, then you want to keep track of that. All right, 145 then. Let's see. We will try to pick this up later. Let me know if you need anything. Hang in there. Hang in there. I mean it. We're going to survive. One way or another, the semester will end. It is finite.
In flames.
We just, I wasn't going to make it dark, but it will end at some point. That's the mantra that I keep repeating to myself. So, all right. See you later. Thanks for being here.